In this video, I'll talk about identifying influential observations in simple linear regression. And a point can be potentially influential in two different ways. The first way, and I'm going to refer to a scatter plot here to make it a little easier to see this. One way that a point could be influential would be if a point was a long way from the regression line in the vertical direction. So maybe up here, or down here, or over here, or over here. And these kinds of points are called outliers. And so they are points that are a long way from the regression line in the vertical direction. In other words, the value of y is either much bigger or much smaller than y hat on the line. In other words, the residual is either really large positively or really large negatively. Or in other words, the absolute residual is very large. The trouble is, the residual is always measured in the same units as the response variable. So by itself, we can't really look at these residuals and go, oh, okay, this is minus 21, that's an outlier. Instead, we have to look at the standardized residuals. And the standardized residuals are designed so that they have an approximate normal distribution with a mean of 0 and a standard deviation of 1 if the assumptions, simple linear regression assumptions, hold. And so we can look at the standardized residuals, and if there's a standardized residual that's way out in the tail of a standard normal distribution, then we might designate it as an outlier. Often the threshold 2 is used, and the reason is because anything beyond 2 is, if we think about it in terms of probability, there's less than a 5% chance that it would be beyond 2. So in this case, for the pizza restaurant example, if we look at all these standardized residuals, none of them are in absolute value bigger than 2. So it doesn't look like we have any outliers in this data set. And we can see that from the scatter plot. Okay, there's no points that are a long way away from the regression line in the vertical direction. The other way a point can be potentially influential is if it was a long way from the rest of the points in the horizontal direction. Okay, let's suppose we had one of the restaurants was and located somewhere where the student population was 50,000. Okay, the largest value in our data set is this one, 26,000. If we had one point that was 50,000, it would be a long way from all the other points. All the other points range between 2 and 26,000. So a point that was 50,000 would be a long way away. And that point would be called a high leverage point. So it relates to these leverages that we calculated before when we were figuring out standardized residuals. And the threshold that's used here to flag a high leverage point is 2 times p plus 1 divided by n. Sorry, 3 times p plus 1 divided by n. Make sure I get that right. So p is the number of predictors. So in simple linear regression, p is 1. So p plus 1 is 2, and 3 times 2 is 6. So in this case, we're looking for anything bigger than 6 over n is 10 in this case. So anything bigger than 0.6 would be a high leverage point. And we can see here none of the points are bigger than 0.6, so there's no high leverage points. And we can see that from the scatter plot too. There's no points that are a long way from the rest of the data. Okay, let's look at some examples where we do have either an outlier or a high leverage point. So here's an example where we have what looks like an outlier in the scatter plot. So most of the data is here, but we've got this point up here, which is a long way from the regression line in the vertical direction. And sure enough, if we calculate the standardized residuals for this analysis, there's one point that's in absolute value bigger than 2. Okay, so that's this point here. And so that's an example of an outlier. And then for leverage, here's an example of a high leverage point. So for this data set, most of the points on the X measurement, on the X variable are in this range between 10 and 25, but there's one point that's way far away, X equals 70. Okay, and if we calculate the leverages for this data set, we can see that that point has a leverage of 0.9401, and the threshold, 3p plus 1 divided by n, comes to 0.86 in this example, and 0.9401 exceeds 0.86, so it's flagged as a high leverage point. And you can see, I've put the regression line on here, you can see the impact of the high leverage point. If we didn't have this point, the regression line would go down this way, right? But with that point, it goes over here. Actually, wonder if I can omit that point and then see what the graph looks like. Let me try and do that. So let's look at the chart design. And I'm going to select the data with that point omitted. And then have a look at how the graph changes. Okay, that did work. Okay, so with that point omitted, the regression line fits the other data much better. If I put the point back in, the regression line goes all the way, gets pulled all the way out here. So that's how a high leverage point can be so influential. If we find a high leverage point, what we want to do is we want to do those two analyses, right? This one and then this one, and see the impact, okay? And then we might want to investigate this point, okay? Maybe there was a mistake, maybe it doesn't really belong in this data set. Okay, we have to think about how we want to deal with this point. Don't simply just delete it because it's inconvenient. Okay, you actually need to think about what's going on here. And then similarly, for an outlier, you can kind of see how the regression line, it's kind of a little higher than it should be. I think it should be kind of a little lower down. This one's going to be a little more awkward because this point is not at the end of the data set, but let me see if I can get this. I'll move it down there. Oh, I lost it. Okay, I think that was because now if I select the data, yeah, it doesn't have the data anymore. Okay, so let's put it back in. Okay, so there we go. So this is with the outlier in. Okay, and see how the line is kind of at the top of the points. It's skirting the top of those 2 points and just below that one. But if I take out that outlier, oh, that was the wrong thing. There we go, this one. If I take out the outlier, then have a look at what happens to that regression line. Okay, see the whole scale changed, so it's a little hard to see, but now that regression line has moved down. Before it was kind of going through these 2 points, and now it's moved down. Okay, so that's the impact of this outlier for this analysis. So again, you'd want to look into this point. Is it a mistake? Does it really belong? Okay, don't simply omit it just because it's inconvenient. So XL stat we looked in the last video about how we can get XLStat to produce the standardized residuals in the output. Unfortunately, it won't give you the leverages. At least I couldn't find a way for it to give you the leverages. So if you want to calculate the leverages, you will have to calculate those by hand, but it's a fairly simple formula, so it's not too onerous. Okay, so that's looking at influential observations or potentially influential observations in simple linear regression analysis.